Hello, we solved this question from WASSCE of the 2013 question 12a, and it says that in the diagram W, X, Y, Z are points on the circumference of a circle, center O. Angle XOY equals 60 degrees, angle YWZ equals 45 degrees, and angle XYW equals 80 degrees. Calculate angle ZYW. So let us look at it again. There is the diagram that we have here. It says that W, X, Y, Z are points. So of course we see W, X, Y, Z. These are points on the circumference of the circle. And the circle has got a center O here. And at the center O, we have an angle here that is 60 degrees. So that is angle XOY. So we have X, that is the point X. That is O, Y. So the angle is here. The angle is shown with an arc. And this sign that you see here is the less than sign, is the angle symbol. So this sign XOY means angle XOY. So angle XOY is 60 degrees. And of course we have angle YWZ to be 45. So that is Y and that is WZ. So an angle is formed when two lines meet. So we have the line YW and WZ, so the angle is formed here, and that is the angle 45 degrees that we see here. And of course we are told that angle XYW2 is 80 degrees. So there is X and there is Y and that is W, and this angle also forms this forms an angle here, and that is 80 degrees here. Okay, so what we've been asked to find the angle ZYW. So let me indicate the angle that we are to find with a red ink or red arc. So we have Z. Where is Z? Okay, here is Z. So ZYW. So that is the angle we are to find. Now, so how can we find this angle? I always tell my students that if you are finding an angle, or if you've been asked to solve or find something, especially dealing with circle theorems, then what you have to do is that you have to ask yourself, what do you have to know before you can calculate that or have that. Now if you look at the diagram very well, you can see that the angle that we are to find, that is the angle ZYW, is in this triangle. That is the triangle ZYW. So we have it here, and we know one of the angles of the triangle. We know the angle here, and that means if we could also know the angle here, that is the angle at the point Z, then we can of course know the angle that we are to find. That is the angle ZYW, because the sum of the interior angles of a triangle is 180 degrees. So the question then is, how can we have the angle here or know the angle here? Now that is circle theorems. We have chords in a circle, so that brings to mind the idea of circle theorems. We have to apply the theorems of circles, and if I want to find the angle here applying a theorem, then of course I'll be looking for a chord that forms this angle. Now this angle is being formed by, or is formed by, the chord WY. Now this same chord WY extends backwards in the opposite segment to form another angle here. So this chord WY forms an angle here and forms an angle there. And I want this angle so that I can find the angle here, because the sum of the interior angles of this triangle should give me 180 degrees. And one of the laws of the theorems of circles is that the sum of opposite angles in a cyclic quadrilateral is 180 degrees. Now there is a circle, and we have 4 points around the circumference of the circle. What are these 4 points? They are W, X, Y, Z. So when you have a circle and you have a four-sided figure in the circle, as we see right now, if you have a four-sided figure like this in the circle, we call this four-sided figure quadrilateral. A quadrilateral is a four-sided figure. But if it is in a circle like this, we call it cyclic quadrilateral, because it kind of looks like a cycle. It goes and comes that way, because when we even rotate it, it appears to be the wheel of, say, a car or a bicycle. So it is a cyclic quadrilateral. And one of the theorems of circles says that in a cyclic quadrilateral, if you have these angles, that is the angles that are facing each other, they sum up to 180 degrees. So if I have here to be A degrees and there to be B degrees, then A plus B is 180. And if here is C and there is D, then of course C plus D is 2 is 180. So that is the idea that I'm trying to apply here. I want the angle here, that is the angle marked with the red arc here. But I also know that the sum of the interior angles of a triangle is 180 degrees. So why don't I try to find the angle here? That's one way that I can solve this. If I can know the angle here, then of course I can sum the 3 to 180 and I will know here. But how do I even know the angle at the point Z? In other words, the angle YZW. I can also find the angle here by considering the fact that the opposite angles in a cyclic quadrilateral add up to 180 degrees. Unfortunately, I don't also know this angle, but I can find this with ease, yes, because I know these angles here, and I can do this because if I know this angle too, I can know the angle over there, applying another circle theorem. Now, that is one way that I can find this angle. Now, another way is to even go straight. I don't even have to find this angle, do I? Of course not. Now, what if I could find the angle here? If I could find the angle here, then of course I must know the angle here, because as I did say, the opposite angles in a cyclic quadrilateral is sum up to 180. So the whole of this angle marked with green arc should be equal to the whole of this angle marked with green arc, and the angle marked with the red arc that I want is within the green arc. So if I take the entirety of this angle, or this entire angle, if I could find this, then that means that when I subtract 80 degrees from the angle that I find here, that is the angle covered by the green arc, then I can find the angle subtended by the green arc or covered by the green arc, sorry, the red arc. Okay, so now let me start to solve this. It seems I've talked a lot, and I'm going to show you what I'm talking about. In solving every question, try to put down the points that you have been given. What do you know from the diagram? From the diagram, I know some angles. The first is the angle XOY. I've been given this angle XOY. I'm told it is 60 degrees. I am also given the angle YWZ. I'm told it is 45 degrees. I've also been given the angle XYW. I'm told it is 80 degrees. Alright, and my question is to find the angle in red ink, ZYH, sorry, ZYW. So what is the value of this angle, ZYW? Okay, so what I'm going to do here is, I know the angle XOY, that is 60 degrees. In circle theorem, not always, but most of the times, it is good to work from the center if you are given an angle at the center. Or you can equally work from any of the angles. If you look at the angle 45, we have the angle 45 here. Angle 45 is subtended by the chord YZ. Does the chord YZ subtend or form any other angle? No, I don't see anything like that. So 45 is over here. Now what about the angle 60 degrees? What can I say about this angle? Oh, the angle 60 degrees is subtended or formed by the chord XY. I'm saying that it is subtended or formed by the chord XY because from 60 you can draw a line to these points. So you can see that the angle 60 is subtended or formed by this chord over there. Now if here is 60, the angle at the point O, that is at the center, is 60, then the angle over here too is 30 degrees. So the first thing I'm going to write here is that I know the angle at W, that is angle XWY. Angle XWY is equal to half of the angle at the center, that is angle XOY. So that is going to be half times 60 degrees, and that is going to be 30 degrees. Now why am I saying this? I'm saying this because one of the theorems of circles says that the angle subtended, that is formed or subtended on the circumference by a chord is half of the angle subtended by the same chord in the same segment. That is very lengthy. You can just say the angle subtended on the circumference is half of the angle at the center, but I just wanted to be very clear here. Now the moment you draw a chord in a circle, you divide the circle into two segments. So if you look at our circle, the chord we are talking about is the chord XY, and you can see that XY goes to the center to form an angle there. So the moment you draw XY, it kind of divides the circle into two segments. That is one of the segments, and the top here, the whole of the remaining area here, is the other segment. Now what do we mean by a segment? When we say a segment is an area. So you can see that the shaded area is what you see. A segment is an area which is bounded by an arc and a chord. So it is divided into two segments, but you can see that the angle 60 degrees is formed in one of the segments. In this case, let me say the major segment, because that is the bigger one of the two here. And from the same chord, we can see another angle being formed at the point W over here. So what we are saying is that if we have a situation where we have two angles which are subtended or formed from a particular chord, or they all come up from a chord, but one of the angles end at the center while the other end on the circumference, and of course these two angles are in the same segment, then we say that the one at the center is twice the one on the circumference, or in other words, the one on the circumference here is half of the one at the center. So the one at the center is always 2 times bigger than the one on the circumference, right? So I kind of used the word or the phrase same segment, because we can also have a situation where they come from a chord, a particular chord. We can have two angles. So one will come from the chord, say the chord XY to the center here, all right, and the other will move away from the segment. So in this case, this law does not hold, because this is one segment here and the other angle is moving away in the opposite segment. So this does not hold it. That is why I try to make it very specific that when we have a situation where the two angles are in the same segment and one ends on the circumference while the other ends at the center, then the one at the circumference or on the circumference is half of the one at the center. So what I'm trying to say here is that the angle at the point W, that is angle here, is half of the angle at the center. So that is 30 here and 60 degrees here. Now if we know the angle here, then of course the entire angle at this point is 75 degrees, because we have here 30 and we have there 45. So we can now apply that law that the opposite angles in a cyclic quadrilateral add up to 180 or is supplementary. So this will be my next step. I'm going to write this. I'm going to say the whole of this angle here, also angle XWZ, angle XWZ, that is the whole of the angle here, XWZ, plus the angle here, that is the whole of this angle here. Sorry, I went too far. Okay, let me draw it again. So from here to there, yes, that is cool. So the whole of this angle here plus angle here, that is XYZ, angle XYZ is 180 degrees. And let me add something small down here. It seems, sir, I have to write it down here. It is so because opposite angles in a cyclic quadrilateral is supplementary. When you say supplementary, it means that they add up to 180 degrees. So you can say supplementary, or you can say add up to 180 degrees. So when you say supplementary, it means that they add up to 180 degrees. Okay. Alright, so let's try to write it down something from here. So that means that the angle XWZ, that is 30 plus 45. So let me write angle XWZ is 30 plus 45, or you can simply say 75, because 30 plus 45 is 75. So plus, let me pull it here, plus angle XYZ, the whole of this angle XYZ. Okay, angle XYZ, I don't know angle XYZ here, but angle XYZ is 80 degrees plus the small angle here I want to find, and that is angle ZYW. Okay, and that is equal to 180 degrees. I hope you are not confused here. Let me try to clarify this here. Now the whole of angle XWZ is this, and the whole of angle XYZ is this, because if you look at XYZ, we have XYZ here, and it comprises this angle here, which is angle XYW, that is 80 degrees here, and this angle that we are to find. So now let me indicate the angle we are finding here. I am indicating it with, you know, a violet color here. So yeah, so this plus that is 75. Okay, I should have added the 82. All right, so let me write 80 here plus this. Okay, that is cool. So now let us make this the subject and find that. All right, so let me add this so that I go on from here. So we have 75 plus 80, and that should be 155. So you have YW, then you have 180. Angle ZYW is equal to 180 minus 155, and then if we subtract this from that, we should get 25 degrees. So the angle we are to find, that is the angle ZYW, is 25 degrees. And let's see, if we had wanted to find the angle here by using this angle, of course we could have done that. How? Because this one is very straight, this one is very simple. But I was talking about using this angle too. Of course we could have. Why? Because if we know 30 degrees here, okay, we also know the angle here to be 80 degrees. So we can consider this triangle. Let us consider it and see. So we are done. But let me write here alternatively. That is, this step is a little bit lengthy. Alternatively, we can consider triangle XWY. So triangle XWY, let me write something here. So I'm going to write considering triangle XWY. So that is what we're going to consider to solve this question. We are going to look at an alternative approach, XWY here. Now the angle here, that is the angle at W, and the angle at Y plus the angle at X should add up to 180 degrees. So if that is the case, then I can know this, and if I can know this, then I can know the opposite side, because the opposite angles in a cyclic quadrilateral add up to 180 degrees. So let me look at the angle at X. So I can call that angle WXY. Let me look at the angle at Y. I can also call that angle XYW, and the angle at W2, I think I can also call it angle XWY. Now this adds up to 180 degrees. Angle WXY, that is the angle at X, is currently unknown. All right, so that is the angle I'm finding. Angle XYW, that is the angle at Y, we know it to be 80 degrees. And angle XWY, that is the angle at W, I think that is 30 degrees. So 180, and WXY, if I add 80 to 30, all right, that should give me 110. And then I will subtract 110, angle WXY equals 180 minus 110 degrees, and that should give me what? Is that 70 degrees? Yeah, that should give me 70 degrees. Okay, so let's go back and look at our diagram. So the angle here is 70 degrees, and if here is 70 degrees, what do you think is the angle here? Tell me. That should be 110, because the opposite angles in a cyclic quadrilateral, as I did say, opposite angles in a cyclic quadrilateral is supplementary or add up to 180 degrees. So here should be 110, and if here is 110, the sum of the interior angles of triangle should be 180 degrees. So what is 110 plus 45? that is 155. So if I take 155 from 180, okay, that gives me 25. So you get the same answer here if you want to go that long route or long way. So one thing that is pretty much important is that if you have a question, you kind of ask yourself, what do you want and how can you get what you want? So we saw that if we could find the angle here, we could sum the interior angles of this triangle and get what we wanted. We also realized that alternatively, and that is pretty simple, we can just find the angle here, because if we know the entire angle here, the opposite angle is in a cyclic quadrilateral, you see, add up to 180, so we can find that. So that is how we solve this question from WASSCE November 2013, question number 12a from Core Mathematics.